Okay, so here we go. We're going to talk about the ductulator. It is used by the duct installation technician to size the ductwork correctly. It can be used for rectangular or round ducts. All right, it considers the volume of the air to be moved, expressed in CFMs or cubic feet per minute. It considers the velocity of the air to be expressed in feet per minute, FPM. It also considers the friction loss expressed in inches of water per 100 feet of duct. You know, you've got air moving through a duct, you're going to get some loss due to friction. Okay, and this ductulator is going to consider that. It's very easy to use. Generally, the student is given two parameters. You log those in, and then you're expected to determine the third. If you don't completely understand the concepts, you can get the correct answers on the exam. So even if you don't completely understand the concepts, you can get the correct answers on the exam. You will probably be required to answer only one or two questions on the exam on the ductulator. Once you see how easy this is, you would probably like to have a lot more than one or two questions from the ductulator. If you are using a different version of the ductulator, the concepts will be the same. It just may be a little more difficult to translate, what you're doing from what I'm getting ready to show you. Okay, so here we go. Trying to get my pointer ready here. Okay. So the first thing I want you to make sure that you're using the English side. There's an English and a metric side. We're going to be using the English side. Okay, make sure you've got the right side. Air volume is in CFM, so it can be read in two different places actually, depending on if you're comparing it to friction loss or velocity. The CFMs are in the window with the white background. So you have air quantity, CFM up here, and you have air quantity, CFM over here. Very good. Friction loss is red right here. All right. You line it up with the CFMs in the white background. Now your colors may be different, but this one is blue for the CFMs. Okay. It is expressed in inches of water per 100 feet. All right. The 100 feet may become important as we proceed, as all ducts are not 100 feet, obviously. Okay, so your findings will need to be adjusted for the duct length. Be careful with the decimal points here. Also note the hash marks between the numbers. Okay, so you've got a 0.1 here, you've got a 1.0 here. Make sure that you're reading these numbers, these decimal points correctly. That can be a big issue for making sure you get the answers correctly on the exam. Decimals and hash marks can be challenging. For instance, this is a 0.1 and this is a 0.2, and so it looks like there's 10 in between. So each one, this would be 0.11, 0.12, 0.13, 0.14, and so forth. Okay. Now between the 0.2 and the 0.3, there's not 10, there's only 5, so it would be 0.2, 0.22, 0.24, 0.26, 0.28, 0.3. So you have to make that adjustment. All right. In this example, we lined up 15,000 CFMs with 0.1 inch of water friction per loss per 100 feet of duct. Okay. The question may have asked what duct diameter would be needed to achieve the 15,000 CFM with the friction loss of 0.1 per 100 feet of duct. And then you could look in this duct diameter window and you would say, well, okay, 38 is the answer to that one. It could be, and it probably will be that simple on the exam. And then we're going to note that you read velocity on the right side over here, where the CFMs are on the top, the velocity is on the bottom here. And expressed once again in feet per minute. If you're given, so if the question gives you, if the givens are the CFM and the velocity, you line it up here, and then you can read everything else from there. All right. So in this scenario, we were given 15,000, okay, CFMs once again, and a velocity of 2,000. So we lined them up this way, 15,000 and 2,000 on the FPM. All right. Now, if the question involves a round duct, once again, the diameter is red in this window right here. If the question involves a rectangular duct, you're going to read one dimension in the green and one dimension down here and line them up, okay? Or, yours might not be green, but that's okay. You're lining one up here and one down here. You line those up opposite each other so they will align the two dimensions, the height and the width of the duct, and then you can read everything else once you line those up. In this scenario, we lined up 10 on the green with 25 on the white for a 10 by 25 rectangular duct. Reversing the sides makes no difference. Okay, notice the hash marks between the written numbers. So this is a 10, 11, 12, 13, 14, and 15, and so forth. It's pretty easy, but believe it or not, some people do have issues with that. So I just want to make sure that we make sure you realize that. Okay, so let's say we had a sample question. The rectangular duct is 20 by 30. The CFM is 10,000. What is the friction loss per 100 feet of duct? Okay, well, they give us the 20 by 30, so we line the 20 by 30 up here. Go ahead and take your duct blader out and do that because mine may not read exactly like yours, okay? And it's not so easy to see. So you just go ahead and grab yours. And so we've got 20 by 30, all right? And then we go up, we line that up, we go up to the CFM up here, which is 10,000. What is across from 10,000 on the friction loss? Okay, and we note that across from the 10,000 you're going to get 0.3. So if we're talking 100 feet of duct, which normally that's the question, they're not going to change that on you generally, but I want you to be prepared if they do. So 10,000 CFM aligns with 0.3. So it's going to be 0.3 inches of water gauge per 100 feet of duct in that scenario would be the friction loss. Now, if the duct were 200 feet long, you'd have to multiply the 0.3 times 2 to get 0.6 inches of water gauge of friction loss. Kind of makes sense. No big deal. You just got to make that adjustment there if it's not 100 feet of duct. If you were asked what the air velocity was in the same scenario, the answer would be approximately 2,500 FPM. Why? Because we're dealing with 10,000 CFM, and across from 10,000 CFM, we get 2,500. Not a big deal. You're starting to get the idea this is pretty easy. It looks complicated, but it's really simple. Okay, and then if you're asked, once again, what would be the appropriate round duct in this scenario, you would read the value in the duct diameter of the window, and you're going to read something like 27. Wow, this is a whole lot easier than it looks. All right, and I want you to tell you that you've been listening to Jack the Exam Guy. My website is jacktheexamguy.com. Please visit. My email, jack@jacktheexamguy.com. And I want to tell you, don't let anybody tell you you don't know Jack. I would like to help you pass this exam and any other of the Florida state contractors exams.